Hello, I'm going to do a quick video on how to size a piece of equipment based on the heat load calculation you get. I'm just going to use the Valtillo house right now. It's in Gulfstown, Texas. So this is the original one that's in your book. And we're going to go down here and we're going to use the numbers that they got to help show you how to size a piece of equipment. Now, if you look down here at the bottom on line 20, you should have added everything up down through here for your total heating and added everything up through down here for your total cooling, sensible. So this is sensible heating, sensible cooling. Down here on line 21, down at the very bottom, you have a latent load too. So I'm going to zoom in on that and bring that up. We can see it real good. Okay. So here we go. This is what we got. We got 28,829 BTUs for heating, 23,918 for cooling, and then 4,364 for latent. Now remember, this had the very leaky duct work and everything that we've been working on. So let's just see what we would do first. So the first thing you want to do is you want to take this latent load here and you want to add it to your sensible. So we got 23,918. And then I'm going to add the 4,364 to it as well. So we got, for a cooling total, if you want to think of it that way, for a cooling total 28,282 and 28,828. So pretty even. It's pretty even kill. Since these numbers are so close to each other, we're just going to use this bigger number right here. Since we're using a heat pump, I know we're going to use gas heat, but since it's a heat pump, we want the heat pump to actually be doing the work, so it'll be more efficient. So we're going to go to the Goodman website, and we're going to use this number 28,828, and I'm going to put it over here on the calculator, so that way we got it. And let's look at what we got here. Close that, and we want to open up the Goodman website. So when you go to the Goodman website, you're going to go to products. And then, like I said, they have air conditioners, heat pump, gas furnace, and package units. We're going to go with the heat pumps. So the first thing on the heat pumps, these are your SEER ratings right here. Like I said, 14 SEER, 16 SEER, 16 SEER, 18 SEER. So we're just going to go with a 16 SEER because it's kind of middle of the road, be a little bit cheaper, and click on it. Okay. When it brings us up, you're going to go down here to View All Documents because we need the manufacturer's data to be able to size our piece of equipment. Now remember, we're working with this number right here, this 28,829, since we're heating and cooling with it. If you was cooling with it and you was doing an air conditioner, what we're about to do, you would size it based on it. If you're doing a heat pump, you want to make sure it's kind of splitting the even of the road. And if you was doing a gas furnace, just to explain that real quick, if you're doing a gas furnace, it must meet or exceed this number. Now, most gas furnaces are like 20, 40, 60, 80,000. So 20,000 wouldn't be big enough to support this, so we would need the 40,000. Okay, so always make sure gas heat, you meet or exceed it. In this case, like I said, what we're wanting to do is try to get the most efficient unit based on the information that we got. So when we bring up the product specs, we see cooling capacities of these are anywhere from 18,000 to 60,000. So there's lots of different tonnage from 1.5 ton all the way up to 5 ton. What you're going to do is you're going to scroll down through all this data, and this sheet here tells you what the model numbers and everything kind of breaks down to. And this is the first thing you run into. We got the 018, 024, 030, 036, 042, 48, and 60. This is all tonnage. Like I said, if you divide that by 12,000 BTUs, that'll tell you what tonnage it is. It's 1.5 ton, and of course 60 would be your 5 ton. This gives you an overall view of the cooling capacities of it. Now remember, ours was 28,000. Excuse me, 28,000. So we're pretty sure we're going to be in this area right here. Excuse me. What we want to do is find the outdoor and indoor coil that just best meets this specific task. So we're going to roll down past all this data here. I believe it's on page 21 if you wanted a quick speed to it. And you'll start seeing stuff like this, performance data, and you're going to start seeing things like this, total BTUs per hour versus sensible BTUs per hour. Excuse me. What we're wanting to look at is this right here, the sensible. Now basically that's what we measured right there, was 28,828. So we want to meet that. Now remember, this is for 99%, 1% of the time. So we want to make sure we're making this number right here. So when you start scrolling down through here, we want to get one that's closest to it. Now, I'm going to talk about a few things here that's going to kind of, be points in this. Remember, we are trying to find the most efficient piece of equipment that fits, but we're also trying to find the piece of equipment that fits. A unit running longer is atypically not so much of a concern as it is, like, depending on how it's built. Is it two-stage cooling, single-stage cooling, all this other type of stuff? You have a lot of things that play into that, but we're talking about comfort, keeping the customer and this block load that we're working on here the most comfortable. So with a number like 28,800, you could round that up and just say 29,000. So any units like this, if you're looking at the sensible on them, this unit is not going to meet our demand. It will make the demand for a vast majority of the time, like 80%. But once it gets past 93 degrees, as we base this calculation on, this unit will not make it. It will not keep that house cool. So we have to have something that is right near this number. Now, total BTUs, that tells you this is total upper end range of it. This is the lower end range of it. We got to make sure this lower end range is meeting this target number. Minimum. That's the minimum we want to make for that right there. So, based on the Valtillo house in Texas with the leaky ductwork and everything like that, we see these numbers here in this column is a lot better than this column up here. So this is 36, so that's a 3-ton. This is a 3.5 ton right here. So we got a 3.5 ton unit. So we're going to be looking at a 3.5 ton unit. This first number here is the outdoor coil. So this will be your outdoor coil. That would be the model. This is indoor coils. There's multiple indoor coils with different setups, maybe a TXV, an AXV, an orifice, an electronic expansion device. But these are the different coils that you can match up to them. So you got 1, 2, 3, 4, 5, 6, 7 different coils that can match up to it. But you see the sensible loads on these are all different. So which one do we need to meet? Well, we would want to get the one that's closest to the number that we got. Like I said, there's 29,000 here. 28,000, a little too small. Extremely close though, extremely close. So these two right here, in my opinion, are very close. But like I said, we know this one meets or exceeds it because we got all the way up to this tonnage up here, but this sensible here is going to help drop the temperature. You're not going to be able to drop the temperature when it gets above 95 degrees if you get one of these units up here. Anything up above this is not going to meet the demand. It will for 70 or 80% of the time, but for the other part of the time, it will not. So basically, let's say this 29,000 one sensible right here. And remember, this is what we're looking at the sensible, because that's what we did, a sensible heating and cooling. This is what we're going to want to try to meet. So my indoor coil will be the ASPT47C14B. So that's going to be your unit right there. That's going to be your outdoor coil, indoor coil match that you would want for this house that's sitting in Gulfport, Texas. Like I said, we're doing a calculation on different. Now, looking at some of the other data they have down here, here's some of the furnaces that you can match up with them. So like I said, and you're going to deal with 1,000,000 BTUs on some of these, like I said. So some of these numbers down in here, like I said, you'll see 40, 60, 80. That's 40,000 BTUs, 60,000 BTUs, 80,000 BTUs. Like I said, these are going to be the numbers. Like I said, ours was 28,000, so there's 40,000 right here. This unit right here, the CA 3F31376A with the TXV and everything, this matchup right here with this outdoor unit, this 18 SEER one, that would be a good matchup. For the 16 SEERs though, like I said, you have a lot more data down through here. Here's some more of the 18s, the 16, the 18 SEER with the air handlers and furnaces. So all you got to do is just roll down through here and find the one that best fits our sensible heating and cooling. So until we hit, like I said, around that 29,000 mark, and now we're starting to get 26,000s, 25, 24, 26, 29. Here we go, 29,000. So once again, we're in the 3.5 ton unit right here. This right here would be our coils and air handlers that we would use, and this would be the furnace that would be selected with it. So like I said, 29,000 here. All of these are 29,000. All these would be great. It'd be perfect. Like I said, it's got the upper end higher than that. We know, like I said, the 60,000, 100,000. Like I said, all these furnaces right here would work, but this would be the one that I would choose right here for that house, because like I said, 60,000 meets and exceeds, well, 80,000, like I said, meets and exceeds what we need, and it'll keep the house where we need to be at. Because here is your other data here over on this side. Like I said, heating rating low and high. So like I said, this is your high end. So there's 40,000 right there. Like I said, it's 39,000. That would work. So all your furnace stuff is over here. And these are, you know, 2 speeds, low and high. So for your heating rating. But like I said, for your sensible cooling, like I said, for the heat pump itself, use the sensible. And for this one right here, we want to look at low and high, like I said. So we know 21,000 to 34,000, that would totally meet that demand on that furnace. But once again, this package over here, like, let's just take a look at this one right here. So 21,000, not big enough to keep our house cool in low speed. But 34,000 is, so that would work. But over here, 25,400 does not meet our sensible heating and cooling that we need. So we're going to have to move to a bigger unit. So that's why I said moving down to a unit like this one here, this meets and exceeds our demands. This will stay in low speed. Extreme weather, 40,000 is going to help out a whole lot more. 29,000 meets our demand. 38,000 way up above it. So this would be the outdoor unit. And this would be your indoor coil, the TXV. And this would be your furnace right there. And that's how you size up the piece of equipment based off your manual J load.